for two isosceles in equilateral triangles. All right, so example 1, how are the bases of an isosceles triangle related? Okay. So first we need to create an isosceles triangle. Try and make one the best I can. Okay, so we've got our triangle, and we know that an isosceles triangle, we have two sides that are congruent to each other. And we know that it is being bisected by a bisector that is cutting the base of it in half. So if I name this A, B, C, our bisector would be cutting A and C equally in half. So this section would be congruent to this section. Okay, so bisector BD Okay, and bisector BD would be evenly splitting this angle in half into two congruent segments. Okay, and that means that the measure of angle DBC is equal and congruent to the measure of angle DBA. Congruence. All right, so that means that angle BCA would be congruent to angle BAC. Okay, and I know that because this right here would be congruent to itself through the reflexive property, because that BD is congruent and equal to BD. Okay, and then I could use side, 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 or I could use side, angle, side to prove congruence through corresponding parts of congruent triangles, that BCA is congruent to BAC. All right, or try it in isosceles triangle ABC. BC is congruent to BA. Reflect the triangles across BC to create an image, C prime, B prime, A prime. What rigid motion maps C prime, B prime, A prime onto ABC? And we want to use that to show that triangle A, or angle A, is congruent to angle C. Okay, so first thing we want to do is we want to create a isosceles triangle. There we go. Again, I'm going to have congruent sides here. We will label it. All right, and it says to reflect the triangle across BA. So if our BA side is right here, we want to reflect across this. And we're going to create an image off of that. I'm going to do my best to create this triangle now. That didn't quite work. Let me try it again. See if I can adjust my size here. Okay, so I think that looks close enough. So again, we have this side that is congruent, and now this side would be congruent. Okay, so then this would be B prime, this would be A prime, and this would be C prime. Okay, so through a rotation around B, we would have a rigid motion. And we can prove congruence between angle A and angle C because we know that C is equal to A prime, which A prime is equal to A because of the rigid motion. All right, so next we're going to look at the isosceles triangle theorem and the converse of that. So the isosceles triangle theorem tells us that if side AB is equal to AC, so AB here is equal to AC here, then we know that angle ACB would be equal and congruent to A or BAC. Okay, and I can see that I have an error in this. So if side AB is congruent, this should be AC. Okay, so this should say AC. So if side AB is congruent to side AC, then angle A okay, so then angle ACB, that one is correct, would be congruent to angle ABC. Okay, so that means that our converse has an error in it. So this should be ABC, and this should be AC. Okay, so that should be fixed on your note sheet. All right, so let's look at our first example using that. All right, example 2, an architect is designing a community park between North 1st Street and South 1st Street. The pathways on each side of the pool will be equal distant or equal in length and will provide effective access and circulation around the pool. To protect the landscape and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners along Park Plaza. What angle measure should the architect specify for the corners in her design? Okay, so we need to figure out what angles we have. They told us that we have a 50-degree angle. Then we need to identify these two angles. We know that those two angles have to be congruent to each other. We know that all of the angles inside of a triangle will add up to 180 degrees. So that means that the measure of angle D plus the measure of angle E plus the measure of angle F would add up to 180 degrees. They told us that measure D is 50. We know that angle E and angle F are congruent to each other. So I can replace angle E with angle F because I know that they're congruent. Okay, and we can do that because we know that the measure of angle E is congruent and equal to the measure of angle F. We have our measure of angle F still, and all of that equals 180 degrees. Now I'm going to combine like terms. Subtract my 50 over. I'm going to go ahead and put that angle inside of a parenthesis. Okay, so I know that 2 of those measure of angle F's would equal 130. So I'm going to divide that 130 by 2, which will give me the measure of angle F, which would be 65 degrees. If the measure of angle F is 65 degrees, that means the measure of angle E would also be 65 degrees. Okay, so she will have to put into the design that the angles of measure for those cobblestones would be 65 degrees. Okay, next we're going to look at the try it. So here they gave us a couple of angles of measure. We know that this is 28 degrees, which means that this also has to be 28 degrees because this is an isosceles triangle. I know that all of the angles inside of a triangle have to add up to 180 degrees. Okay, and then I would add all of the interior angles together. So 28 plus 28 plus the unknown angle, so 5x plus 9. Combine like terms. Subtract my 65 over. And then divide by 5. Okay, so my x would be 23. All right, B, again, they want us to find the value of x. This time they didn't give us this top angle. This time they gave us our two angles that are congruent to each other. So if these two angles are congruent to each other, I can set those two measures equal. So I would have 4x plus 9, and I would set it equal to 8x minus 3. And now I'll just solve for x. So I'll move a variable over. Add my 3 to the other side. And then divide to get rid of the 12. So I would find that my x equals 1. All right, next. What are the lengths of all three sides of the triangle? So this time they gave us our side measures and not our angles, but I know that these two sides are equal to each other, so I can set those two equal to each other, solve for x, and then plug in x. Okay, so first thing I want to do is get rid of the 3 that is underneath 8x. So right now it's dividing 8x, so the opposite of division. I will multiply by 3x. I need to multiply the entire left side by that 3. So I get 3x plus 60. And I'm just left with 8x. I will move a variable. And then divide by 5. So I'd get 12 equals x. So I've solved for x, but I don't want to know x. I want to know each of the side measures. So let's start with P, or PQ, I should say. PQ is 6x, where x is 12, minus 12. So once I solve that, I would get 60 for that first side. Then I'll do PR, which is x, so I'm going to plug in 12 plus 20 So I'd get 32. Right, my QR should be the same as PR, so I should find 32, but I'm going to go ahead and plug it in to check it. So I'd get 8 times x, which is 12, divide by 3. Once I solve, again, I would get 32. All right, so those are all of my side lengths. Okay, the try it, we want to find the value of x. They gave us all of our side lengths. We need to solve for x. Okay, so on this one, they tell us that these two angles are congruent, which means their opposite sides have to be congruent. Okay, so if those sides are equal, I can set them equal to each other. Move my variable. Add my 1 over, and then I can divide. Okay. All right, so we solve for x on that one. Next, what are the lengths of all 3 sides of the triangle? So the last part of this, we solve for x. Now what it's wanting us to do is plug in that x for each of our variables. Okay, and I know that 3/2 is the same as 1.5, so I can either use 3/2 or 1.5. I'm going to use 1.5 just because I like dealing with decimals better than fractions. Okay, so once I plug that into my first side, I would get 11. So that would be for, oh, we don't even have angles. My next side, again, I'll plug in the 1.5. I know this side should equal 11 because it's congruent to the opposite side, but I will double check it, and when I do, I also get 11. Okay, last side. And then finally, I get 14 for my last side. Okay, next we're going to look at bisector of an isosceles triangle. If a line or line segment bisects the vertex angle of an isosceles triangle, then it is also the perpendicular bisector of the opposite side. Okay, so if I have an angle, my vertex angle, and I have a bisector on it, it is creating a perpendicular on the opposite side. So I'd be creating a perpendicular on that base side. Okay, so if AB is congruent to BC and our measure of ABD is equal to our measure of CBD, so these two angles are congruent to each other, then we know that BD is perpendicular to AC. And that because it's a bisector, our two base sides it's creating are congruent to each other. Okay, so let's look at example 4. A prefabricated house is delivered to a foundation in 2 symmetric halves that are assembled on site. Along the planned route to the site, the truck must pass under a bridge that has a clearance height of 17 feet. Should the trucker plan a different route for delivering the house? So we want to see if this house is under 17 feet tall. So right now we can see that we have 10 feet up here to the roof, and our hypotenuse side on the roof is 16 feet, but we don't know the altitude, this height right here. So we want to be able to find that measure so we can find the total height of the house to the very top of that house and make sure that it is under 17 feet. Okay, I know that I can use my Pythagorean theorem to find my missing sides. And I'm only missing one side because I know that this entire base is 28. This entire base is 28. Half of 28 would be 14, so each of these is 14. So now all I'm looking for is this missing side, which is the height that I'm looking for. So I'd be using my Pythagorean theorem, and I know that my Pythagorean theorem is a squared plus b squared equals c squared, where c squared is my hypotenuse, which would be the 16. And then my a and my b are the other sides. So I can set this up, a squared plus b squared, my b would be the 14, so 14 squared, equals c, which is my hypotenuse, 16 squared. I'll go ahead and find the square of 14 and 16. Subtract my 196 over. So I get a squared equals 60. To get rid of a square, so I have the a squared, to get rid of that square, I take the square root. So the opposite of a square is a square root. I'm going to take the opposite of that square, the square root, to get rid of the square. That just cancels out my square. So a equals the square root of 60, which when I simplify 60 would be 7.7. So this height right here that I didn't know would be 7.7. I want to figure out the total height, so I would take 10 plus that 7.7 to get 17.7 feet. So the question was, is the truck driver going to have to plan a different route? Will they have a bridge that is 17 feet for clearance? This house is not going to fit under it, so yes, they will have to find a different route. All right, try it. What is the measure of RSQ? So RSQ, we're trying to find that angle measure. We know that this is 31 degrees. We're creating a perpendicular bisector, so those would both be 90 degrees. All right, I know that my perpendicular bisector is cutting my angle S in half, so creating two congruent pieces. So if I can find this angle, I know it's equal to the one that we're looking for. So if I can find that angle, I would be able to solve this. I already know two of the angles. I have 31 and that right angle, which is 90 degrees. I know that all of the angles inside of a triangle add up to 180 degrees. So I know that this 180 degree triangle would be all of the sides inside of it added together. So the one that we don't know, I'm going to call X, plus the 90 that we know, and the 31 that we know. Now I'll solve for X, and I would find that the missing angle is 59 degrees. Okay, and X is also the missing angle that we're looking for. So the measure of angle RSQ would equal 59 degrees, as well as the angle we found. Right, next we're looking for PR. So we're looking for the measure of PR, which is that entire side. I know that my perpendicular bisector is evenly splitting that base in half. So I know that this 4 would have to be congruent to this missing side PQ. So I would have 4 plus 4, plus 4 So PR would be 8. Okay, then equilateral triangles. Through equilateral triangles, we know that if angle A is congruent to angle B is congruent to angle C, then side AB would be congruent to BC and AC. And I can see that this is not labeled right. So A, B, and C. Okay, similarly, going backwards, if side AB equals and congruent to BC is congruent to AC, then we know that angle A would be congruent to angle B, would be congruent to angle C. All right, next we're going to prove that equilateral triangles are equiangular. So we want to prove that angle D is congruent to angle E is congruent to angle F. We are given that side DE is congruent to EF and DF. Okay, so through our equilateral triangles, we know that DE, if it is congruent to EF, then we know that angle E would have to be congruent to angle F. And similarly, we know that if EF is congruent to DF, then angle E would be congruent to angle D. Therefore, D would be congruent to angle E, would be congruent to angle F. Okay, next we're gonna prove that equilateral triangles are equiangular. So now we're given the angles and we want to prove that the sides are congruent. So we're just going to go backwards using that equilateral triangle theorem. So we know that if angle G is congruent to angle H, so G and H, then we know that GJ would be congruent to HJ. Similarly, we know that if angle G is congruent to angle J, then side GH would be congruent to side HJ. So that would prove that GH is congruent to HJ is congruent to GJ. Okay, next we want to look at the triad. What rotation can be used to show that the angles of an equilateral triangle are congruent? Okay, and so by having 120 degree rotation and having the triangle map onto itself, we would be able to prove that it is equilateral. All right, example 6. Prove that equilateral triangles are equiangular. This time they give us that the measure of CBD, so this entire measure is 130. And we need to find what BAD is. So we're looking for this angle right here. Okay, so we know that with an equilateral triangle, all of the angles are congruent to each other, and that all of the angles inside of an equilateral would be 60 degrees. So this would have to be 60, this would be 60, and then this portion of that one would be 60. So then I can find the other half of this 130 by subtracting the 60 that I know, which would give me 70 for this other portion. So for ABD, that would be 70. So now I have one of my angles for my isosceles triangle. I know that the two angles opposite of this have to be congruent to each other. There are 180 degrees in the triangle. We know that one of the measures is 70 and that the other two angles are congruent to each other. That should be equal. Okay, so I'm going to subtract the 70 over. So I'm left with 110 and 2 of these x's. I'll divide that 110 in half. So each of these isosceles triangles angles would be 55. So my measure of angle BAD would be 55. Right, what is the measure of U? We're given one angle here. We have two isosceles triangles. I know that this angle would be congruent to this angle. So first I'm going to find that missing angle. So 180 would equal the 72 plus 2 x's, because I don't know what those are. I will subtract 72. And then divide by 2. Okay, so each of these measures is 54. I need to find this angle now. I know that these two added together would add up to 180. So I'm going to take 180 and subtract the 54 that I just found. Which will get me 126. So this angle right here, I found to be 126. Now I know all of the measures inside of my other triangle are 180 degrees. I don't know what these two base angles are, but I know that all of these will add up to 180. So I'll call those X, subtract the 126. And then divide by 2. So that means that the measure of U equals 27 degrees. Let's look at the try it. Find each angle measure in the figure. We are given no angle measures. Well, I see that I have a equilateral triangle, so I know this has to be 60, and this would be 60, this would be 60, and that would be 60. I know that these two added together would be 180. So 180 minus the one angle that I do know will leave me with 120. Okay, and we're looking for the measure of angle P in O, which we found to be 120 degrees. Okay, next we're going to look for NOP. So NOP is this angle. I have an isosceles triangle, so I know that all of those have to add up to 180 degrees, and that I know one of the angles, but I don't know what the two congruent angles are, so we're going to look for those. So I'm going to be left with 60 divided by 2. So each of those angles, so the measure of angle NOP would be 30 degrees.